Hello students, and welcome to the video or this lesson on estimating integrals using the midpoints. And there's not much to this if you are already familiar with LRAM, RRAM, and the trapezoidal rule. The thing that's a little bit different is we're going to use midpoints, and in this particular case we're asked to use 4 rectangles. Okay. And since it doesn't say which particular ones, we'll assume equal sizes. Okay. So first I'm going to do what I normally do, which is sketch out what this equation looks like. Okay. That's what the graph roughly looks like. And now we're going to break this up into 4 equal sizes, and we want to go between 0 and 2, just as the problem asks. So that means we're going to have rectangles at 0, at 1/2, at 1, and at 1.5. Okay, so this is 1 here, this is 1.5, and this is 2. Okay. Now the thing about midpoint is that, you know, for RRAM, or the right rectangle, you use this length. For the LRAM, you use the leftmost stick. Okay. And for this, well, we just find the midpoints between here, and we use that to form the rectangles. So that's going to be one of our rectangles. Let me use a different color pen here. Here's the midpoint. So some of this is going to overestimate, and some of these will underestimate. Okay. So these green rectangles here are the sizes, and the height of the rectangles are calculated using the midpoints of the existing rectangles. Okay. So to recap, we first start out by drawing the bases of these rectangles, and then we decide how to find the height of the rectangles by using the midpoint of the bases and extending that to the function. Okay, so this point here is going to be f of 1.75. Okay, so that's the midpoint between 1.5 and 2. This point right here is going to be f of 1.125, because 1.125 is the midpoint between, this is 1.25, because that is the midpoint between 1 and 1.5. This point here is going to be f of 0.75. And then this point here is going to be f of 0.25. And so the integral is approximately equal to f of 0.25 plus f of 0.75 plus f of 1.25 plus f of 1.75. All of that times the length of the bases here, and each of the length of the bases here is still 1/2. Okay. So plug these numbers into the function, add them all up, and divide them by 1/2. So once all that's done, I get that the estimate is, of course, about 13.625. So there you go, a pretty solid, straightforward example on how to use the midpoint rule. But as always, I will pose some questions for you to think about. And the first question is, under which conditions, and it's really just all the same question, Under which conditions will the midpoint method overestimate, and under which conditions will it underestimate? Okay. And second question I can ask is, if you were to compare the midpoint method to LRAM, RRAM, the trapezoidal rule, which ones will produce the largest values, which ones will produce the smallest values, and under which conditions? Okay. So compare estimates of RRAM, LRAM, the trapezoidal rule, and the midpoint rule, and rank from smallest to largest value. And maybe you can start with just this particular function, and then you can think to try to extend and stretch your thinking to all possible functions. What is it about the function that is going to allow us to order these from smallest to largest? These types of problems will definitely show up somewhere on the AP exam if you're taking an AP course. Even if you're not taking an AP course, it's good to exercise your brain on these types of questions. Thank you for watching, and have a wonderful day.